Queues are stacks' brother-in-arms. Stacks are first in, last out, but queues are first in, first out, aka FIFO. These make a lot more sense at face value and in the real world. You wait in line to try and buy a new PlayStation 5 or Xbox Series X. Whoever gets there first is the first person allowed in to buy them, and then the second person who arrived, and this process continues until the scalpers have bought up all the supply because their bots arrived microseconds after the line was first formed. Now, it should be pretty obvious why queues are useful. Running a restaurant, oldest orders go out first because that customer has waited the longest. Some hot new mystery anime is airing this core. Definitely want to watch that in release order, and as soon as it comes out, to keep up with the plot and not get spoiled. Now, queues operate with the methods push, same as a stack, putting it at the end of the list, and pull, which grabs the thing at the head of the list instead of pop, which grabs the last thing. These correlate to add last and remove first in linked list land. And we also have a peek method here, which works exactly like peek in stack land, except returning the value that pull would instead of pop, aka the oldest value. Now, for Java, things are kinda wonky. They don't really follow normal conventions or have simple versions of queues like they do with stacks. I'm going to use the simplest variant that offers basic queue functionality, but pay close attention to the names because we're throwing everything I just said out of the window. Now, let's go to our stack example that I have down below, convert it to a queue just to see how it changes. So we're going to alter our stack of type string line to be a deck of type string called queue, and that's going to equal a new array deck, because a queue is a deck in Java, apparently. Really, it implements the interface like a couple others, but this is the simple one, so we're just going to stick with this. Now, we're going to change all references of stack to queue. We're going to change our pop to pull, and we're going to change our push to offer because Java is aggravating and doesn't want to follow the universally agreed upon naming conventions for how a queue works. Okay, so now we're going to run it, and we see Bulbasaur, Ivysaur, Venusaur, Bulbasaur, Bulbasaur, Ivysaur, Venusaur, which is the exact order the queue should print them out in based on what we did. Lastly, just like how stacks are super useful when doing tree and graph algorithms, queue are equally as useful in slightly different ways. So keep them in mind as we move further into the data structures and algorithms world. And, well, that's all I have. Queues are pretty easy to understand, especially after you've seen a stack. So let's see you in the How It's Made video next time. Like, subscribe, and comment below what you want to see next or topics you'd like to know more about.